Hello everyone. Feels like it's been a long time since we've done vocabulary. So this is vocabulary for chapter 6, algebra. Some of these words should be review from previous years and some of them will be brand new this year. I believe there's 10 words altogether, so you should be able to do this. Here we go. So set it up like this if you didn't remember. Ooh, cool color. And what I'm going to do is I'm going to show you all the definitions for these three first and kind of go over them. You'll probably want to hit pause if you need more time to write. But we've got the three words power, exponent, and base. Um, Power is an interesting one because a power isn't a noun. A power describes a number that has an exponent. The exponent is actually the number that it's being raised to, and the base is the number that is the big number that's written down. So I'm going to be quiet here while you write these down, and then I'm going to explain. So hit pause if you need time to write these down. Okay, so you should have had time to write these down. If you didn't, hit pause or go back and hit pause. And so if I take away this, I did one big example for all three of these vocab words. So this over here is the base of 2 with the exponent of 3. And you never usually say 2 to the third exponent or something like that. You would say it's 2 to the power of 3 or 2 to the third power. That's the idea of the power is it's not a thing, it's a way to explain what exponent it is to. This would mean that you would do 2 times 2 times 2. So if you are going to do this out, an exponent multiplies by itself, 2 times 2 times 2. And that should definitely be review. If that's new to you, then we need to talk. Okay, hit pause if you need more time on this slide. Go to the next one. One of the things we're going to talk about in this chapter is scientific notation. Scientific notation is a method of writing numbers in terms of a decimal number between 1 and 10 multiplied by the power of 10. So this is the number. It's called a coefficient. And then you multiply it by what base of a 10 it has. So this has 10 to the 23rd power, we would call it. This is written in scientific notation, and it's a way of writing very large and very small numbers. You don't use it all the time. You only use it with numbers that are really, really big or really, really small. We'll go over that in class. This is an 8th grade standard, so you should be comfortable with scientific notation. Next one, exponential function. So hit pause if you needed more time with that. An exponential function. So this is a function, just like you can have linear functions. This one is nonlinear, so that's kind of an important part of this. It's nonlinear, right there. It has a variable for an exponent and changes by the same factor over time. You'll recognize it by its multiplying. And notice how weird this is. That's the key. Do you see that the exponent is a variable? You've never dealt with something like that before. So this is going to be something that's going to be brand new to you. Exponential functions. They have really cool graphs that don't make straight lines. That's why they're nonlinear, right? So they don't make straight lines when you graph them, and they're growing by multiplying by the same number. Okay, hit pause. Exponential growth is when a quantity increases by the same factor over equal intervals of time. And then there's also exponential decay, when a quantity decreases by the same factor over equal intervals of time. I just noticed that I don't have an example for these two. Notice that growth is increasing, decay is decreasing. Exponential growth, a good example of that is cells dividing. So as cells divide, like when something is growing, a plant or an animal is growing, their cells are actually each dividing, and then each of those cells divides, and then each of those cells divides, and that's an example of exponential growth. Exponential decay is the opposite. When something dies, like a animal dies, it cells start to break down and it decreases by the same factor over time. So everything is decreasing and getting smaller and decomposing the same over time. It's a cool thing called carbon dating. In carbon dating, they can tell how old bones are because of this idea of exponential decay. They can date it back working backwards and see how quickly it's decaying now and go back to where it started. That's my really basic explanation of exponential decay. So I don't really have any other examples over here for you. Ignore my phone. Okay, next. Wait. Okay, answered the phone really quick. Here we go. Last page, geometric sequence. Geometric sequence is an ordered list of numbers in which the ratio between each pair of consecutive terms is the same. So this guy is an example of a geometric sequence. Whoops, I didn't want to use that. I'm going to use like a pin. So if you go from 2 to 4, and then if you go from 4 to 8, and if you go from 8 to 16, how are those all changing? They're all multiplying by 2, multiplying by 2, multiplying by 2. So this guy is a geometric sequence. This one down here, how is it changing? This one is going to 6. This one's going to 7. This one's going to 8. So this one is plus 1 every time? That is not a geometric sequence. So this one is a yes. This one is a no. Hey, that's a pretty good cursive yes. So the geometric sequence has to be in which the ratio between each pair of consecutive terms is the same. If I made 2 and 4 into a fraction or a ratio, it would be the same relationship as 4 to 8. That would be the same relationship as 8 to 16. These guys, if I write it as a fraction or ratio, 5 over 6, that is not the same thing as 6 over 7. That's not the same thing as 7 over 8. So if you want the extra credit for listening to this, next to the top one, put a yes, and next to the bottom one, put a no. If you write that yes and that no, you'll get extra credit on this assignment for listening to the actual video. Okay. Common ratio. So the common ratio is the ratio between each pair of consecutive terms in a geometric sequence. So the ratio here is what we were talking about before. Since this guy, oh, come on. Since this guy is being multiplied by 2, that's the common ratio, is 2. If I wrote it as a ratio, it would be 2 over 1. Because 8 is 2 times as big as 4. That's the common ratio. 16 is 2 times as big as 8. That's the common ratio. So the common ratio here is 2. That's what your common ratio would be. I think that might be it. That's it. Okay, be ready for your test or your quiz. I think there's just 10 questions. It should be pretty good. See you later.